All right. So picture this. It's April 14th, 1935. Black Sunday. The worst dust storm in American history is about to hit the Southern Plains. Around 3 in the afternoon, a wall of dirt, a mile high, stretches across the entire horizon, from Kansas down through Oklahoma, clear into the Texas Panhandle. People who saw it coming said it looked like the end of the world. And honestly, for thousands of farmers watching their topsoil disappear into that churning black cloud, it might as well have been. The storm moved at 60 miles per hour. No warning. 1 minute you're looking at blue sky, the next everything goes dark. Not twilight dark, not nighttime dark, pitch black. Middle of the afternoon and you couldn't see your hand in front of your face. Static electricity from all that dust made car engines die, knocked out telephone lines. The dirt got everywhere, into houses through cracks you didn't even know existed, into your lungs, into your food, into everything. By the time it passed, 3 million tons of topsoil from Texas, Oklahoma, Kansas, and Colorado had been ripped from the earth and deposited as far east as Washington, D.C. and New York City. Ships 300 miles out in the Atlantic Ocean reported dust falling on their decks. But here's the thing. This wasn't just some freak natural disaster. This was man-made, every bit of it. See, for decades, farmers across the Great Plains had been using moldboard plows, the kind that turned the soil completely over, burying everything. Neat, clean furrows. Looked beautiful. And for generations, that's how you farmed. That's what you did. You plowed deep, you turned that prairie sod upside down, and you planted your wheat, or your corn, or your cotton. The problem, those moldboard plows destroyed the very thing that held the Great Plains together: native prairie grass. Grass with root systems that went down 6, 8, sometimes 10 feet into the earth. Roots that had been holding that soil in place for thousands of years through droughts and heat waves and everything nature could throw at it. When farmers plowed all that grass under, when they exposed bare dirt to the sun and wind for months at a time, they created a powder keg. All it took was a drought, and boy, did they get one. The drought started in 1932. 7 years. 7 years of almost no rain. Crops failed, wells went dry, and all that pulverized topsoil with nothing to hold it down just started blowing away. First in little dust devils, then in massive storms that buried entire towns. By 1933, the crisis was undeniable. 100 million acres, think about that number, 100 million acres of American farmland was being destroyed. Not damaged, destroyed. In December 1935 alone, 850 million tons of topsoil vanished into the atmosphere. Farms were buried under drifts of dirt that looked like snow. Families abandoned everything they owned and headed west, desperate for any kind of work. The government tried to help. The newly created Soil Erosion Service sent experts to teach farmers about terracing, contour plowing, planting trees as windbreaks. It helped, but it wasn't enough. Because at the end of the day, farmers still needed to work their fields. They still needed to plant crops, and they still needed to use plows. And that's where our story really begins. In a tiny town in the Oklahoma Panhandle called Hooker, Oklahoma, there was a farmer named Fred Hamey. Now, Hooker, Oklahoma wasn't exactly on anybody's map. Still isn't, really. Population maybe 600 people back then. Middle of nowhere, flat as a tabletop in every direction. The kind of place where you could see the dust storms coming from 50 miles away. Fred Hamey was watching his farm blow away just like everybody else. But Fred, he was the kind of guy who couldn't stop tinkering, couldn't stop watching how things worked. And one day in 1933, he was watching a road crew working on a highway near his property. The crew was using scarifiers, heavy equipment with pointed shanks that ripped into compacted road surfaces. And Fred noticed something interesting. When those scarifiers tore through the ground, they kicked up big clods, big chunky pieces of dirt. And those big clods, they didn't blow away in the wind. They were too heavy, too large. They just sat there. Now look at his plowed fields. Powder, fine as flour. The slightest breeze, and it was gone. Fred went home that night and couldn't stop thinking about it. What if instead of turning the soil over and pulverizing it like a moldboard plow did, what if you just ripped through it? What if you broke up the hard pan underneath without bringing all that loose dirt to the surface? What if you left the stubble from last year's crop right there on top as a kind of protective blanket? It was a radical idea. It went against everything farmers had been taught for generations. Your field was supposed to be clean, neat. All that old crop residue was supposed to be buried or burned. That's how you controlled weeds. That's how you prepared a proper seedbed. But Fred Hoeme looked at his fields turning into desert and he thought maybe it's time to try something different. He started sketching designs. Heavy frame made from hefty H-beams, long shanks, vertical blades that would penetrate deep into the soil, and at the bottom of each shank, a chisel-shaped point. Not a curved mold board that turned dirt over, not a disc that chopped everything up, just a simple chisel that would rip through the ground, break up compaction, but leave most of the surface undisturbed. He hitched the thing up to his tractor and made a pass across one of his fields. The chisel plowed cut down 6, 8, sometimes 12 inches deep. It shattered the compacted layer underneath. But when he looked back, the wheat stubble from last year's crop was still standing, a little roughed up maybe, but still there, still covering the ground, still protecting the soil. And when the wind came, that precious topsoil stayed put. The big clods the chisel plow created were too heavy to blow away, and the stubble acted like a net, catching and holding everything in place. Fred Hoeme had just invented what would come to be known as the chisel plow, and he had absolutely no idea that his rough-looking farm implement was about to change American agriculture forever.
So Fred Hoeme's got this contraption that actually works. Problem is, he's just one farmer in the middle of the Dust Bowl, and the Dust Bowl doesn't care about one farmer's clever invention. But word spreads fast in farming country, always has. When something works, when something actually helps a farmer keep his land from blowing into the next county, people notice. Fred's neighbors started showing up. They'd heard he built some kind of new plow, something different. Could they take a look? Fred, being Fred, said sure, and he didn't just show them, he let them watch it work. Now imagine you're a farmer in 1934. You've been fighting this drought for 2 years. Your kids are coughing up dirt. Your wife is stuffing wet rags around the windows trying to keep the dust out. You're watching your topsoil, your livelihood, literally blow away. And then you see Fred Hoeme's field. Still has stubble on it, still has clods big enough to resist the wind. The soil's still there. You're gonna want one of those plows, immediately. Fred and his sons started building them in their farm workshop. Nothing fancy, they weren't manufacturers, they were farmers who happened to know how to work metal. They'd forge the shanks, attach the points, weld up the frames, one at a time. When they finished one, they'd sell it to a neighbor, then build another one. They made about 2,000 plows this way. 2,000 from a farm workshop. Think about that kind of demand, that kind of desperation. Now, the technical details here are important because they explain why this thing worked when everything else was failing. Those manganese steel shanks weren't just tough, they were flexible. Just flexible enough. When the chisel point hit a rock buried in the soil, the shank would bend slightly, absorb the impact, then spring back. This was crucial in the Great Plains, where glacial rocks from the last ice age were scattered everywhere underground. The reversible chisel points were another stroke of genius. See, the points took a beating, grinding through 8-10 inches of compacted soil mile after mile. They wore down fast. With a traditional plow, you'd have to take it to a blacksmith, get new points forged and fitted. Lost time, lost money. But Fred's design? You just unbolted the point, flipped it around, bolted it back on. 5 minutes. Back to work. And those 16-inch sweeps for weed control, they were designed with a specific curve, a specific angle. Too steep, and they'd bring too much dirt to the surface. Too shallow, and they wouldn't kill the weeds. Fred tested and adjusted until he found the sweet spot. The sweeps would slice through just below the surface, cutting off weeds at the roots, but leaving that protective blanket of stubble intact. Here's what was happening underground. When you ran a moldboard plow, you created a hard layer about 8 to 10 inches down, called a plow pan. Years of turning soil at exactly the same depth had compressed the subsurface into something almost like cement. Water couldn't penetrate it. Plant roots couldn't penetrate it. It was like putting a concrete floor under your crops. Fred's chisel plow shattered that plow pan. Those long shanks punched right through it, breaking it up, creating channels for water to infiltrate, spaces for roots to grow. And because the plow wasn't inverting the soil, wasn't burying everything, all that organic matter from previous crops stayed near the surface where it belonged. This created something soil scientists would later call stubble mulch tillage. That layer of crop residue on top acted like a mulch in a garden. It shaded the soil, keeping it cooler. It slowed down evaporation, helping whatever rain did fall actually stay in the ground, instead of immediately evaporating in the brutal plains heat. And critically, it created a rough, cloddy surface that resisted wind erosion. The Soil Erosion Service, the federal agency created to fight the Dust Bowl, started paying attention. They sent scientists to look at Fred Hame's fields. They measured soil loss. They compared erosion rates between moldboard plowed fields and chisel plowed fields. The results were stunning. Fields worked with the chisel plow lost a fraction of the soil compared to traditional plowing. In some cases, erosion was reduced by 75, 80, even 90%. This wasn't marginal improvement. This was transformational. But here's where the story gets interesting, because Fred Hame was a farmer, not a businessman. He knew how to work metal, how to build things, how to farm, but manufacturing, marketing, distribution, that wasn't his world. By 1938, he and his sons were exhausted. 5 years of building plows one at a time in a farm workshop, while also trying to run a farm during the worst drought in history, it was too much. Fred knew the chisel plow needed to reach more farmers, a lot more farmers. But he didn't have the resources to make that happen. That's when William T. Graham showed up. W.T. Graham was a businessman from Amarillo, Texas. Amarillo sits in the heart of the Texas Panhandle, right in the middle of Dust Bowl country. Graham watched the same storms Fred Hame watched, saw the same destruction, but Graham also saw an opportunity. He approached Fred with a proposition. Sell him the manufacturing and distribution rights. Let Graham build these plows at scale, with real manufacturing equipment, real distribution networks. Get them into the hands of every farmer in the Dust Bowl region who needed one. Fred said yes, and honestly, it was probably one of the best decisions he ever made, not for himself financially, but for American agriculture. Graham moved fast. He set up a proper manufacturing facility in Amarillo, not a farm workshop, a real factory. He brought in industrial equipment, hired experienced metalworkers, established supply chains for steel. He modified Fred's design slightly, strengthening it to handle the bigger, more powerful tractors that were becoming available. And then he did something brilliant. He branded it. The Graham-Hoeme Chisel Plow, the plow to save the plains. That slogan wasn't just marketing hype. It was the truth, and Graham made sure every farmer in the Dust Bowl region knew it.
1939. The drought is still going. It's been 7 years. 7 years of watching the sky and praying for rain that doesn't come. But something's changing on the ground. You start seeing these Graham-Hoeme chisel plows everywhere across the plains. And more importantly, you start seeing something you haven't seen in years. Fields that aren't blowing away. Graham's Amarillo factory is running at capacity. They're producing hundreds of plows, then thousands. The demand is almost impossible to keep up with because farmers are finally seeing something that works. Not a government program that tells them what they should do, not a theory from some university professor, an actual piece of equipment that demonstrably keeps their soil where it belongs. Now, the technical evolution happening at Graham's facility is fascinating because farm equipment in the 1930s and 40s was in this weird transition period. You had old-style equipment designed to be pulled by horses or mules, and you had newer tractors that were getting more powerful every year. The chisel plow had to work with both. Graham's engineers kept refining the frame design. They added adjustable spacing between shanks. See, different crops needed different tillage patterns. Cotton farmers wanted shanks spaced one way. Wheat farmers wanted them spaced another. Sorghum growers needed something else entirely. By making the spacing adjustable, one plow could handle multiple crops. This was huge for small farmers who couldn't afford specialized equipment for every situation. They also developed different point configurations. The original double-tipped chisel points Fred designed worked great for most applications, but Graham's team created specialized points for specific conditions. Breaking hardpan, use a narrow, aggressive point. Shallow cultivation, use a wider sweep. Rocky soil, use an extra reinforced point that could take more punishment. And here's something not many people talk about: the spring-loaded shanks. Early chisel plows had rigid shanks, solid steel. When you hit a rock, the whole machine stopped, or worse, something broke. The shank bent, the frame twisted, you were done for the day. Graham's engineers started experimenting with spring mechanisms. The shank would be mounted on a heavy spring so when it hit an obstruction, it could kick back, lift up over the obstacle, then snap back into position. This was absolutely critical for making the plow practical in the northern Great Plains, where glacial rocks were a constant problem. This innovation triggered a bizarre legal battle that would eventually reach the Supreme Court. I'm not kidding. The chisel plow became the center of one of the most important patent law cases in American history. Graham versus John Deere Company established the modern standard for what counts as a genuine invention versus an obvious improvement. But that's a whole other story. By 1941, the drought finally broke. Rain came back to the plains. And you know what? The farms that had been using chisel plows survived. Many of the farms that hadn't, didn't. The difference was stark. Fields that had been chisel plowed still had topsoil. They had organic matter in the ground. They had soil structure. When the rain came, they could plant crops again. The soil could support growth. Fields that had been moldboard plowed for years, that had been left bare and exposed, that had lost inches or even feet of topsoil to erosion, those fields were essentially bed. You could plant in them, sure, but the yields were terrible. The soil quality was shot. It would take decades to rebuild what had been lost. And then, just a decade later, the second test came, the 1950s drought. 1950, rain stops falling. Again. And not just for a year or two. This drought lasted 7 years. 7 years. Exactly like the 30s. But here's what was different. By 1955, about half of all Great Plains farmers owned chisel plows. Half. That's not a niche tool anymore. That's mainstream agriculture. The Soil Conservation Service, which had replaced the old Soil Erosion Service, had been promoting something called stubble mulch farming since the mid-1940s, and the chisel plow was the primary tool for doing it. They taught farmers to leave crop residue on the surface year-round. They showed them how to work their fields without inverting the soil. They demonstrated how breaking up the plow pan improved water infiltration. This wasn't just theory anymore. By the 50s, there was a decade of solid research backing up what Graham-Hoeme had figured out through observation and experimentation. Soil scientists could measure everything: moisture retention, organic matter content, erosion rates, root depth, yield improvements. And when that 1950s drought hit, the data was undeniable. Areas where chisel plows and stubble mulch farming had been widely adopted, erosion was manageable. Dust storms happened, sure, but nothing like the 30s. Nothing close. Areas where farmers had stuck with traditional moldboard plowing, it was the Dust Bowl all over again. I want you to understand what a close call this was for American agriculture. If the chisel plow hadn't been invented, if it hadn't been adopted widely enough in the 1950s, that second drought could have finished what the first one started. The Great Plains might have become permanently unusable for farming. The breadbasket of America could literally blown away. Instead, the chisel plow, this simple-looking implement that Graham-Hoeme invented in a farm workshop, became the foundation of what we now call conservation tillage. Every modern no-till planter, every minimal till system, every piece of equipment designed to work soil while leaving crop residue on the surface, they all trace their lineage directly back to Graham-Hoeme's design. The American Society of Agricultural Engineering in the year 2000 designated the Graham-Hoeme chisel plow as a historic landmark of agricultural engineering. They put it on the same list as the farm tractor, the self-propelled combine, and the International Harvester cotton picker, the most important agricultural innovations of the 20th century. And honestly, it belongs there.
So by the 1960s, the chisel plow has proven itself. It's not experimental anymore, it's not controversial, it's just standard equipment. But here's what's interesting. The impact goes way beyond just preventing erosion, because when you change how you work soil, you change everything else downstream from that. You change crop yields, you change moisture management, you change organic matter buildup, you change the entire ecology of the field. Farmers started noticing their yields improving. Not immediately, not in the first year or two, but over time, fields that were chisel plowed consistently produced better crops than fields that were moldboard plowed, especially during dry years. Why? Water. It all came down to water. Or more specifically, how soil holds water. When you moldboard plow, you're creating this beautiful, smooth surface. Looks perfect, but that smooth surface creates what's called sealed soil. The first rain that falls on that bare dirt and immediately starts compacting it, creates a crust. Water can't penetrate, it just runs off, takes topsoil with it. With a chisel-plowed field, you've got that rough, cloddy surface with stubble all over it. Raindrops hit the stubble first. Their energy is absorbed. They don't impact the soil with enough force to create that sealed crust. And those big clods create pockets and channels where water can infiltrate. Research from the USDA's Agricultural Research Service showed that chisel-plowed fields could hold up to 30% more moisture than moldboard-plowed fields. 30%! In a semi-arid climate where every drop counts, that's the difference between a crop and a crop failure. Then there's organic matter. This is huge. Organic matter is basically decomposed plant material in the soil. It's what makes soil dark and rich and fertile. It holds nutrients, it holds moisture, it provides food for all the beneficial bacteria and fungi and earthworms that make soil alive. Moldboard plowing destroys organic matter. When you turn soil over, you're exposing all that organic material to oxygen and sunlight. It oxidizes, burns off, disappears. You can actually see this happening. Take a field that's been moldboard plowed for decades and dig down. The soil is pale, almost gray. It's dead soil. It's mineral particles with almost nothing living in it. Chisel-plowed fields, because they're not inverting the soil, because they're leaving residue on top that slowly breaks down naturally, they're building organic matter. Studies from the University of Nebraska showed fields that had been chisel-plowed for 10, 15 years had double the organic matter content of similar fields that had been moldboard plowed. And here's where it gets really interesting, because by the 1970s, researchers started looking at something called the soil carbon cycle. This was new science, the idea that soil isn't just a medium for growing plants, it's a massive reservoir for carbon. Turns out, soil holds more carbon than the entire atmosphere, and how you manage that soil determines whether that carbon stays locked up underground or gets released into the atmosphere as carbon dioxide. Moldboard plowing releases carbon, big time. You're exposing organic matter, it oxidizes, carbon goes into the air. Chisel plowing, minimum tillage, no-till farming, they keep carbon in the ground. They're actually pulling carbon out of the atmosphere through plant growth and locking it into the soil as organic matter builds up. This wasn't why Graham-Hoeme invented the chisel plow. He was trying to stop wind erosion, but he accidentally created one of the most important tools for carbon sequestration in agriculture. By the 1980s and 90s, the conservation tillage movement was in full swing. Equipment manufacturers were producing increasingly sophisticated versions of Fred's basic design. You had offset chisel plows for working around obstacles, deep ripping chisels for breaking up severe compaction, combination tools that could chisel, level, and plant all in one pass. John Deere, Case, International Harvester, every major equipment manufacturer had multiple chisel plow models, some of them 20, 30 feet wide, able to work 50, 60 acres an hour when pulled by modern high-power tractors. But it all traced back to that original Graham-Hoeme design. The basic concept never changed. Long shanks, chisel points. Work deep, leave residue on top. Now, was it perfect? No, nothing ever is. Chisel plowing had its challenges. Weed control was tougher. When you moldboard plow, you bury weed seeds deep where they can't germinate. Chisel plow leaves them near the surface. Farmers had to rely more on herbicides or mechanical cultivation. This created some environmental concerns about chemical use. In wet climates with heavy soils, chisel plowing sometimes created drainage problems. That rough surface could hold too much water. Fields would stay wet too long, delaying planting. And there was still the issue of equipment cost. A good chisel plow wasn't cheap.
Small farmers, especially in developing countries, often couldn't afford them. But the benefits outweighed the challenges. And as equipment evolved, as farmers learned better management techniques, as researchers solved problems one by one, conservation tillage became more and more effective. Today, over 100 million acres in the United States are farmed using no-till or minimum-till systems. That's about a third of all cropland. And while no-till is even more conservative than chisel plowing, it wouldn't exist without the groundwork that chisel plowing laid first.
Here's where this all connects to today. Because the story of the chisel plow isn't just history, it's ongoing, it's happening right now. Every time a farmer makes a decision about how to work their soil, they're participating in a conversation that Fred Hamey started back in 1933. The fundamental question is still the same. How do we grow food without destroying the land we're growing it on? Modern agriculture faces challenges Fred Hamey never imagined. Climate change, population growth, water scarcity, soil degradation, happening not just in the United States, but globally. We need to feed 8 billion people. Soon to be 9, then 10, and we need to do it sustainably. Conservation tillage, the movement that Fred's chisel plow started, is more critical now than it was during the Dust Bowl, because the stakes are even higher. Let's talk numbers. In the United States alone, conservation tillage practices prevent an estimated 2 billion tons of soil erosion every year. 2 billion tons! That's soil that stays in fields, growing crops, instead of washing into rivers or blowing into the atmosphere. The carbon sequestration is equally impressive. Conservation tillage systems are storing an estimated 50 million tons of carbon dioxide equivalent annually in U.S. soils. That's like taking 10 million cars off the road. And globally, if conservation tillage was adopted on all suitable cropland, it could sequester up to a gigaton of carbon dioxide per year. Water conservation is another huge benefit. In places like the Ogallala Aquifer region, that's the massive underground water source that supports agriculture across the Great Plains, water levels have been dropping for decades. Conservation tillage helps by improving moisture retention, reducing irrigation needs by 15 to 30% in many cases. And here's something Fred Hamey would have appreciated: fuel savings. A farmer using no-till or minimal-till saves anywhere from 3 to 5 gallons of diesel fuel per acre compared to conventional tillage. Multiply that across millions of acres, you're talking about hundreds of millions of gallons of fuel saved every year. But implementing these systems isn't always easy, especially in developing countries where the Dust Bowl story is playing out right now. Sub-Saharan Africa, parts of Asia, South America, these regions are experiencing the same kind of soil degradation the Great Plains saw in the 30s, plowing up marginal land, losing topsoil to erosion, experiencing crop failures and food insecurity. Organizations like the Food and Agriculture Organization are promoting conservation tillage in these regions. They're literally taking the lessons learned from Fred Hamey's invention and applying them to modern crises. They're showing farmers how to leave crop residue on fields, how to minimize soil disturbance, how to build organic matter. The equipment looks different now. In Africa, you might see a simple ox-drawn chisel plow instead of a $100,000 tractor-pulled implement, but the principle is identical. Disturb the soil as little as necessary, leave residue on top, protect what you have. There's also been this fascinating evolution in technology. GPS-guided tractors that can chisel plow following the exact contour of the land to minimize erosion, variable depth tillage that adjusts how deep the shanks go based on soil compaction readings taken in real time, sensors that measure moisture content and organic matter and adjust the implement accordingly. But you know what's interesting? The basic design Fred Hamey came up with, shanks, chisel points, break-up compaction without inversion, that hasn't changed because it doesn't need to. The physics work. The principle is sound. In 2000, they dedicated a historic marker in Hooker, Oklahoma, right there in Fred Hamey's hometown. The American Society of Agricultural and Biological Engineers put up a plaque explaining what Fred accomplished. Fred Hamey died in 1978. He lived to see his invention become standard across the Great Plains. He saw it save farms during the 50s drought. He saw it become the foundation of conservation agriculture. But I don't think he ever fully grasped just how important what he did was. He was just a farmer trying to save his land. He saw a problem, he observed something that might work, he built a tool, he shared it with his neighbors.
That's it. No grand vision, no master plan. Just one person, in one place, at one moment in time, paying attention. And that simple act of observation, that willingness to try something different, that stubborn refusal to accept that the land had to blow away, it changed everything. Today, when you drive through Kansas or Nebraska or Oklahoma or the Texas Panhandle, you see fields, productive fields, growing wheat and corn and sorghum, fields that are still there because somebody 90 years ago decided to do things differently. The Great Plains didn't become a permanent desert. The breadbasket of America didn't blow away. Not because of government programs, though they helped, not because of university research, though that was crucial, but because a farmer named Fred Hamey in a town you've probably never heard of, in the worst environmental disaster America had ever faced, watched a road crew and had an idea. And that idea became the plow that saved the plains. That's the story. That's how one man's simple observation revolutionized American agriculture. That's how we learned to work with the land instead of against it. That's how we're still farming the Great Plains today. And that's why, every time a farmer drops a chisel plow into the ground, they're carrying on something Fred Hamey started. They're part of a tradition that says the land matters, that soil is worth protecting, that we can grow food and preserve the earth at the same time. If that's not worth remembering, I don't know what is.